Okay, so in tonight's lesson, this is actually 39B, and we are still in the section that's evaluating limits. Oh, you can't even see this. We're still in the section that's evaluating limits, um, but in this lesson we're going to see that direct substitution doesn't always work, and there's other analytical ways to determine the limit. There aren't any words worth knowing on here, but there are a couple things that you will need to know, and the buzzword that you may not even remember is conjugate, but we'll go over those in the foldable. So I just mentioned that sometimes direct substitution doesn't work. So if you open up and look at this first example, yesterday we learned that you can essentially just plug in the value that you're approaching and get the limit. But that doesn't always work because sometimes there are holes in your graph or asymptotes. If you think back to our first lesson with limits, you can kind of visualize examples where we had a hole or an asymptote and the limit may have existed or it may not. But we can't really tell by just plugging in, because what's going to happen here is negative 3 plus 3 in the denominator gives you 0. And we can't have a 0 in the denominator. So over here I want you to write direct substitution doesn't always work. We're going to watch out for zeros in the denominator. Okay, so what are we going to do if we can't plug it in? Well, the front kind of gives it away, but we're going to use factoring to help us out a little bit. Remember, this is all doing it without looking at a graph. We could type this in a graphing calculator and we can figure it out pretty quickly, but without a graph we have to factor. So we're going to take this expression and we're going to do some work on it. So we're going to say x squared, what am I doing? I don't know. Over here, we're supposed to go over here now, and I'm supposed to talk about factoring a little bit. So blast from the past, let's try to remember, how do we factor something that looks like this, the numerator? Well, it's a trinomial, and the a equals 1, so this is the easy method of factoring. So whenever we were in Algebra 2, I taught you that if it is in standard form, then you can look for factors of c that add up to b. So write that over here, factors of c that add up to b. And so usually I would put my constant over here, and I would find the factors, and there would be 2 of them, and then you would plug them in the parentheses like so. So that's how you factor. So when we go back over here, what are my factors of c that add up to b? So what are the factors of negative 6 that add up to 1? And if you think about that for a little bit, to multiply to get a negative number, we're going to have one positive factor and one negative. And the positive factor is going to have to be bigger to get this positive b. So let's do 3 and negative 2. If you add those together, you do get positive 1, so that's correct. So now we're going to plop those two factors in the parentheses like this. So we'll have x plus 3 times x minus 2 all over x plus 3. Now what's convenient about this is that there's the same factor on top and bottom, which means they can cancel. So this factor can cancel with this factor, and now all we have left is x minus 2. And I've been avoiding writing my limit notation, but now we need to write limit as we go. And now that we no longer have a denominator, we can actually evaluate this by plugging in -3, and the answer is -5. Hopefully yours is a little bit more organized than that. Sorry. But that's how you do it.